Here's how to write a whole number in scientific notation. Remember that there's always an implied decimal point to the right of a whole number. We'll move the decimal point to the left until only one digit remains to the left of the decimal point. We need to count how many places we're moving the decimal point. We moved the decimal point 4 places. The 4 becomes our exponent. We can get rid of those meaningless zeros at the right. We can also write numbers between 0 and 1 in scientific notation. We need to change the form, but not the meaning, so that there's just one digit to the left of the decimal point. As we move the decimal point, we count the number of digits we've passed. The power of 10 is the negative of this number. Here's why. Scientific notation describes this decimal as 7 9/10 times 100,000th. The fraction can be rewritten in exponent form as 10 to the negative 5th power. As the world shrinks and people from different countries share information, we need a common system of measurement. Most countries use the units of the Système International. The fundamental SI, or metric units, are the meter for length and the kilogram for mass. The United States is the only major country that doesn't use SI units for everyday measuring. SI units are easy to use because they're based on powers of 10. Most of us have heard words like mega, which means million, kilo, which means thousand, centi, which means hundredth, and milla, which means thousandth. Computer users have probably heard the words giga, which means billion, and micro, which means millionth. A computer company sells hard drives that can store 80 billion bytes. We could write this in scientific notation, but that's not very useful because we have no word for 10 to the 10th power. But there is a word for 10 to the 9th power. We can replace 10 to the 9th power with the prefix giga. Now that's the way to advertise computing power.